Today we will be solving this trio of questions, beginning with number 1. So we have a right triangle. Assume that these two triangles are congruent. Let D be the intersection. We want to find the area of this union over this area. Okay? Anyway, so here's the thing. We can drop down this height because that's going to help us find the area of BDC, right? Now, we know that BD is equal to DC because these two angles are congruent. Because they're corresponding angles of congruent triangles. This angle is congruent to this angle, meaning these are congruent. And we also know that this angle plus this angle is 90, but this angle plus this angle is also 90. So, therefore, this side is also congruent to this side. And then we realize that this is half of this total area. Why? Well, this part to this part, it's a linear 2-to-1 scale ratio, right? So the area is multiplied by 4. So this is 1/4 of the area. So this whole thing is then 2/4, which is 1/2. So this is 1/2 of the total area. This is 1/2 of the total area. This is 1/2 of the total area. So the whole thing is 3/2 of the total area. BDC is only 1/2, so the answer is 3. Okay, next we go to here, isosceles right triangles. Now, in isosceles right triangles, you can just use the symmetry of the thing. So this is 2, 2. We can just suppose that's 2, 2. Then this is 4, 0. Yeah, so you can assign numbers to points to make the calculation a little bit easier. So if B is 0, 0, then BM has slope 1/3, meaning AD has to have slope of -3, meaning this point is 8/3, 0. And then if we drop down this height, because, well, we want to use tangent, right? So we have to try to relate tangent to the other angles. And we can also use the fact that the sum of these angles is 180. Right? So the thing is, if we know the tangents of these angles, then we can find this. So it turns out that this distance is 3 minus 8/3, which is 1/3. And then this is 1. So tangent of angle MDC is 3. And then we also know that this tangent, well, this is just 45 degrees because it's part of this whole triangle. So tangent of MCD is 1. And then we have that here. I'll just use alpha here and beta here. And then this is theta. So we know that alpha plus beta plus theta is 180 degrees. If you take the tangent of both sides, you get tangent of alpha plus beta plus tangent of theta over 1 minus tangent alpha plus beta times tangent theta is 0. So this part actually cancels out, and we can ignore it. So what is tangent alpha plus beta? Well, that is just tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta, which is -2 if you plug in these values. So that gives tangent of theta is equal to 2. So 0, 0, 2 is our answer. Last question. This looks like a problem where we can use Menelaus off the bat. Right? So we can just set up our Menelaus with K as our outside point. So what does this become? CK over KB. And note that we do have a KB, we do have a CK, which suggests Menelaus is a good idea. CK over KB times BF over FA times AE over EC is 1. Now, it wants like these on top and bottom, so maybe we should switch this up. KB over CK times FA over BF times EC over AE is equal to 1. And then we also have a dB and a DC here. So that's just using Siva's theorem. So CD over, maybe we want dB on top. So BD over DC times CE over EA times AF over FB is equal to 1. Meaning KB over CK is equal to BD over DC, and now we realize why we put BD on the top, because then we can multiply this by this and this by this to cross multiply. Right, so we have KB times DC is equal to CK times BD, meaning this ratio is equal to 0, 0, 1.